Guys, here we go. When you were in Algebra 2, and I'm going to try to make it as simple as possible. When you were in Algebra 2, does this sound like an Algebra 2 problem right here? Find two numbers whose sum is 20 and whose product is as large as possible. Do you guys remember that? So usually you probably did this. Two numbers that sum up to 20. Sometimes they call this a restrictive equation. And those same two numbers whose product is as large as possible. So I'm going to say P equals XY. And when you were in algebra, they probably told you, let's see, what did they probably tell you? They probably told you to use your restrictive equation to come up with a model, y equals negative x plus 20. And then this is your y, that's your second number. I'm going to plug that in there. Product equals x times negative x plus 20. And I agree with you to a certain extent that you don't necessarily need calculus for that question. You can just type it in here. You can just go x times negative x plus 20. And this is my product. And if I want the largest product possible, I just look at a graph from 0 to 20 because those are my two extremes there. And there's no such thing as negative area, but I want to see the x-axis. So that to 120. And then I push graph. And then there it is. So the product of so where do I have the biggest product? Right up there. So you just tell the calculator. Second calculator, number 4, maximum. Where do I want you to look? I want you to look between here and here. And that's what you guys did in Algebra 2. You guys didn't have Algebra 2 during the pandemic, did you guys? Okay, so there it is. So what have to be the dimensions? 10 by 10. So 10 by 10. 10 by 10 creates largest area. How will we do this with calculus? Well, you already see it. I hope you see it. Look, that's a max. So find the derivative, and then where your derivative is 0, that's where you have your max. So check it out. If I were to distribute this, P equals negative x squared plus 20x. Take a derivative, P prime equals negative 2x plus 20, bless you, equal it to 0. So if I were to go negative 2x equals negative 20, x equals 10. And there it is. If x is 10, plug it in here, and then y is 10. And check mark, because I'm only looking between 0 and 20. I guess I don't have to do it that way, but you don't have to write any of example 1 down because example 1 is probably not going to ever be asked, at least not like that because that one's too simple. But example 2, no, I just wanted you guys to take that in, like to just observe. Example 2 is legit. A rectangle is to be inscribed under one arc of the sine curve. What is the largest area of the rectangle can have and what dimensions give that area? Okay, it's a little bit of pre-calc, but not extreme, just baby pre-calc. Does everyone know how the sine curves looks like? All right, does everyone know what the question is even asking? I have a rectangle inscribed under one of the arcs of the sine curve. So here's sine x. I'm exaggerating it. So let me use black. I'm exaggerating it, guys. That's sine x. I know that this is x equals 0 over here, and way over there, I know that that is x equals pi, because this is y equals sine x. I have a rectangle embedded, and which rectangle should I draw? Don't draw both of them, just draw one. Should I draw this one? Will that one give me the best area, the max area? Or will it be this one right here? Let me do it in a different color. Will that one give me the largest area? Or will it be a super long one? Let me do a different color. Will this one give me the largest area? Do you guys see the conundrum? So they want to know what is the size that gives you the biggest area of that rectangle. So create a model. That's the hardest part. I'm going to write it right here. I'm going to put create a model. That's the hardest part, guys. I'm going to try to go as slow as possible. So let's see. We know that right smack in the middle, and you guys are going to help me out. Right smack in the middle, I know that that is pi over 2. So that's where sine has a max. Sine of pi over 2 is 1. What is the value of that? 1. Yay or nay? Uh-oh. Okay. area. So let's see. I guess a restriction. Restriction. Well, I guess first we got to come out with a model first, right? So what is the size of this red rectangle right there? Size or dimensions? Dimensions. Okay. All right. I'm going to try and go slow. I don't know. I'm just looking at it and I'm thinking this. Here's what I'm thinking. I know that the distance from the origin to that red one there, that is just some x value. Do you agree? Okay, but I don't, Chav, why does that matter? Well, if this is some x value, then the distance from here, oh, that's not the right one. I'm looking at the red one. The distance from here, the red one, all the way to there, that should also be that same x value. Yes or no? Okay, so think about it. What do you think, and I'm going to see if I can bold it. What do you think this bolded red segment is? That green segment is x, that green segment is x. So that width is what? Pi? Did I hear someone say pi? No, no. The distance from the origin all the way to here is pi, so I can go pi, and I'm going to subtract what? 2x. Guys, follow along, guys. Try really hard. Look, this is just some distance x. Chop, how do you know it's some distance x? Well, that's the origin. So if I go, I don't know, 1.5 and that's 1.5, it's symmetric about this axis, so that's also 1.5. You guys see what we did? So if I want this distance, bam, if I want just that guy, I gotta go pi minus this, and that will give me just that distance. You guys see that? Now the height is dictated by the curve. The height is dictated by the curve. Write that down. Height is dictated by curve. What curve? Well, this curve. What curve is that? Yeah, say it. Yeah, y equals sine x, or height equals sine x. That's the curve, guys. So here it is. So I'm going to write height equals sine x. So what's the model? Area of my rectangle is equal to pi minus 2x times sine x. That's my model. That's how you get the area of rectangle. How do we feel? Right, restriction. My restriction is going to be by the width here. Notice that says pi over 2, so x cannot be, x has to be between 0 and pi over 2. I guess if I put a equal sign here, then I have no area because you're both extremes. Chav, I don't have no idea what you're doing. Okay, all I'm doing is restriction, guys. Look, I can only be so, that width can only be so long or it can be so short. If I were to make x equal to pi over 2, then I have no rectangle because you're right up against that. If I make x equals 0, then I have no rectangle because I'm right up against that. I'm super skinny. Like if I say x equals 0.00001, then you have a width of a rectangle like that. And it's very, very small. If I say x equals, like, let's say I'm 0.001 away from pi over 2, then you have a real, real slim rectangle, but super tall. You guys see that? So because of the extremes, the area is 0, whatever critical number I get, if I get one critical number, that must be a max. And a lot of these, you can just play that game. You can always do the derivative sign test, guys. See that the derivative changes from positive to negative at that point. But because we only get one critical point, that is the only critical point that creates the max area. Cool or not cool? Okay. All right, guys, that's it. We're done. We're just, what do you think is easier? Should I distribute this sine x? We're just going to take a derivative. Area equals pi sine x minus, I already started distributing, too bad. 2x sine x. We're going to have to do product rule anyways, but all right. Let's take a derivative, a prime. I probably should have left it alone, but too bad. I already did that. All right, derivative of pi sine x is just pi cosine x. That's all it is. minus, and I'm going to put a bracket because I'm going to do product rule right here. First times derivative of the second plus second derivative of the first. I'm going to equal this to 0. Let's see if it's a pretty number or if we're going to have to use our calculator. A prime equals, yeah, you have to use a calculator, guys. Pi cosine x minus 2x cosine x plus 2 sine x. Unless you have a trick to get the cosines and sines to be one cosine or one sine using like a composite argument property from like your pre-cal days, cosine A plus B, cosine A minus D. We're not going to do that. Just take this number right here and equal it to 0 in your calculator. So I'm just going to type it in. So I'm going to go to y equals, and let's see, what was it again? Pi cosine x. Pi cosine x. Yeah, make sure you're in radian mode. Minus 2x cosine x minus 2x cosine x. And then we'll do it with algebra just in case, you know what I mean? Plus 2 sine x. I didn't distribute the negative. Negative, negative. Yep, negative. Thank you, Zalali. I should start offering something, like maybe a point, right, or something. Let me change that plus to a minus. All right, guys. All I care about is where across the x-axis. All right, check it out. Notice what I told you. This is the only critical number I have. It's going to cross the x-axis from positive to negative because it's a max. So check it out. I'm going to click on window. I only care about 0 to pi over 2 because that's my restriction. And let's hover around. So I'm going to go -1 to 1 and 0.5. Check it out. Graph. Voila. Positive to negative. There it is. Second calculate. Number 5. Focus, guys. Focus, focus. First, why did I put 5? Second calculate. Number 2. To the left of that. Enter. To the right of that. Enter. Voila. That's the number I have to be for you to be a max. And we'll play with it right now. 0.71. I can't memorize that. Let me see. X. Enter. 0.710462. 0.710462. X equals 0.710462. All right. Here we go. It wants my dimensions. Ready? We almost got it, guys. We just need the dimensions. How do we get it? We just plug it in here. Into this. This by this. See? Width and height. So sine x. I'm just going to go sine. Why doesn't my mouse work? Sine of this number. That is my height. And then what was my width? Pi minus 2x. That is my width. Okay, so I'm going to put, what do I have right here? Dimensions that give max area of, what was my max area? That times that. All I'm doing is length times width. 1.1221 of 1.1221. Dimensions that give max area of 1.2 is colon height equals, or the height, 0.65218. 0.65218, at least 3 digits after the decimal. Width equals 1.72066. That's truncated. 1.72066. And there it is, guys. And now, because we know, if you wanted to, you can just do algebra now. You can just type this into your Y1 and see that it's going to be, that's your max area. Let's do it real quick. You don't have to do this, just listen or just observe. If I were to go to Y equals, and then I'm going to clear this, I'm just going to type that in answer. I'm just going to type sine x times pi minus 2x. Check it out, guys. This is my max area. Window, 0 to pi over 2, and I know that the area is 1.22, so I'm going to go to 1.5. Check it out. Graph. Look, I'm going to tell it second calculate because we're not fake here. Number 4, max. And then look, the max is well, somewhere in there, so I'm going to push enter here. And we're going to get that answer, that 1 point blah, blah, blah. Check it out. Keep going, buddy. Come on. Somewhere here. Guess? Nah. Look, 1.1222. And look what the x value is, 0.710. Isn't that cool? You guys don't think that's cool? I think that's cool. All right, guys. Check it out. Look at this. Now you want a box. I stole this. I'm going to try to see if I can start quoting wherever I took it from. I took it from Demana because I didn't make pictures like this. To optimize something means to maximize or minimize some aspect of it. What is the size of the most profitable production run? That's business calculus. What is the least expensive shape for an oil can? What is the stiffest rectangular beam we can cut from a 12-inch log? We usually answer such questions by finding the greatest or smallest value of some function that we have used to model the situation. Isn't that cool? Like, you can actually see calculus here, guys. An open top box is to be made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin and bending up the sides. So here's my sheet of tin. How large should the squares be to make the box hold as much as possible? What results in maximum volume? Look, isn't that cool? So you have, what do you have? A 20 by 25 inch sheet of tin. Oh, I gotta be careful there. And you're cutting the corners to make the biggest possible volume. So look, here it is. Here's your 25 by 20, and here are the corners that you're cutting. And look, when you fold it up, here's the box. And you got to figure out how much to cut to make the biggest volume. So there's your calculus problem. You don't think this is cool, guys? I think this is so cool that you can use it. So first, what's the model? First, model. All right, so first, yeah. So volume, this is what you want to maximize. So this is what you're going to take a derivative of. So x times 20 minus 2x times 25 minus 2x. That's my volume. There it is. Next, my restriction. Well, let's see. Restriction, which one's the smallest? 20 minus 2x. Okay, so x has to be between 0 and 10. And then I'm going to put a hint. Hint, look at 20 minus 2x.
Is this an example in which they give us a model?
No, they didn't give us a model, so we have to come up with it. 2 times 10, 20. Yeah, there it is. There it is, guys. Child, why is the restriction between 0 and 10? Because of the 20 minus 2x. 10 times 2 is 20. 20 minus 20 is 0. Do you guys see that? You can't have negative volume. We're talking about positive volume. Cool or not cool? Okay, here's the beauty of it. You can check it if you want. Because of the restriction, if you only have one critical number, I think this gives us 2, but we're gonna. I think one of them is egregious. Is that the word that you guys use in algebra 2? That it's negative. Because of the restriction, if you get one critical number within the restriction, that's it. That's your max. If you get another critical number that's outside of the restriction, then that's egregious. Like, you don't care about it because it's not possible. Does that make sense, guys? All right, don't worry. This one requires the use of a calculator, so we're not gonna do a whole bunch of stuff other than, take a derivative of that model. You could do a triple product, but don't make life harder for yourself. Just distribute. So I'm gonna do this first. I'm gonna distribute this, and I'm gonna turn it into a polynomial. So 20 times 25. So v equals x. Let's see, if I have 20 quarters, is that $5? Yeah, so 500. 20 times 2x minus 40x. And then 2x times 25 minus 50x. 2x times 2x plus 4x squared. Did I do that correctly, guys? Did I not do something? Did I do something wrong?
No, I just have a question.
Oh yeah, I'm about to.
Oh, okay.
I'm about to. This is negative 90x. So here's what I have. I'm about to, miss. Yeah, I wasn't done yet. You're ahead of me. Too fast, too furious. 80x squared. Oh, tough crowd. So there it is. This is what I'm going to take a derivative of because this is what I want to maximize. Does that make sense? This is whatever you want to maximize or minimize is what you're taking a derivative of, guys. V prime equals 500 minus 180x plus 12x squared. I could factor out because they're all even. I'm not going to bother. We're just going to do it with a calculator. What route do you guys want to go? Like see where it crosses the x-axis, or do you guys want me to use the quadratic formula? See where it crosses? Okay. Type this into y1, guys. Try it with me so you guys can practice. So y equals, I'm going to type in, what am I going to type in? 500 minus 180x plus 12x squared. All right, there it is. All I care about, I know it's going to be a max, so it's going to cross from positive to negative. I'm going to click on window. I'm going to change my x min to 0. I'm going to change my x max to 10. And you just care about where you cross negative to positive. So y min, -1. Y max, 1.5, that's fine. Graph. And look, you have 1. You have 1. In case you want to see it, well, you know what? Maybe it's better to see it. Because maybe some of you want to graph. It's not much better. That's fine. Look, there it is. You read a graph left to right, and it's going from positive to negative, so that's my max. Second, calculate number 2. And then left bound, 1, 2, 3. Nope. Left bound, put 3, push enter. And then right bound, I'm going to put 4. 4, enter. And then it wants me to guess. I don't care. If there was multiple ones, you would go to the one you're closer to. But there's only one, so push enter. And there it is, guys. 3.6811. There it is, guys. That's a dimension. X equals 3.6811. This is inches. Inches. Oh, what the heck? Inches. All right, that's the height. So what are dimensions? Dimensions, colon. Let's see, the width. I'm going to say that the width is equal to 20 minus 2 times 3.6811. And I'm going to see what that is. So I'm going to go second quit. You know what? I'm going to go ahead and push. I'm going to put this into a letter, guys. Store that into alpha A. That way I can just use A. So 20 minus 2A. 20 minus 2A. And I get 12.6376. 12.6376 inches. And then I'm going to say width length. I'm going to say length is 25 minus 2x. So minus 2 times 3.6811. So 25 minus that. So 25 minus 2a. And I get 17.6376. 17.6376 inches. And then my height is just the x, which is 3.6811 inches. And then the volume is just multiplying. Max volume is, and then just multiply all three of those. So I'm just going to take my calculator. Yeah, it is heavy on the calculator, guys. So I'm just going to go this guy times the 17 times alpha A. I already had it in here as A. 820.528. 820.528 cubic inches. There it is. What do you guys think? Are you guys liking this? It's kind of cool. I think it's kind of cool. This one doesn't have a restriction equation. So it's a little different because I can use as much material or as little materials as I want. Oh yeah, do you guys know that too? Okay, we're gonna skip this momentarily. We'll come back to it tomorrow, probably. All right, guys, go to this one because this one we're gonna assign you guys, and that's all we're gonna talk about. This is all we're gonna do for modeling. We're just gonna do this, the one activity, and the UH, and then be done. All right. Find the coordinates of the point on the curve y equals square root of x plus 4 that are closest to the point 7, 0. Okay, we're going to do a hack on this one because this one can get ugly super fast. So here's how this looks. -4 is over here. And it opens up like that. And then I'm going to say 7, not to scale. 7, 0. And they want, what do they want? They want that. Is that the shortest? Or is this the shortest? Or is perpendicular maybe the shortest? They want to know that. Or maybe this is the shortest. That's not the shortest, obviously. Because that's the distance of 7, 8, 9, 10, 11. That's the distance of 11 if you're going through the x-axis. So they want to know a point on the curve that is closest to 7, 0. So that utilizes the distance formula. Do you guys remember the distance formula? It's the same as Pythagorean theorem if you think about it, because they're the same. Distance formula is the square root of the change in x plus the change in y. It's just Pythagorean theorem, guys. Okay. Let me tell you the hack. Let me help you with the logic. This is what I want to find the smallest. Oh, I didn't mean to hit it so hard. Sorry. All right, this is what I want to find the smallest of. You know what I mean, guys? So do yourself a favor. Do you want to work with chain rule? I mean, it's going to be chain rule no matter what, but see how you have a square root on top of this expressions? Get rid of the square root because the max and the min, the smaller the expression is, the smaller the distance is going to be. Does that make sense to you guys? Okay. What's smaller, square root of 2 or square root of 9? Because the 2 is smaller than 9. What's smaller, square root of 1/4 or square root of half? Square root of 1/4 because 1/4 is smaller than a half. So what I'm trying to tell you guys is we're trying to find the smallest expression possible. So to make life easier for you, get rid of the square root. Does that make sense? Okay, so let me put it in here. It's a hack. So when you go to the university and the professor talks to you, say, Professor, can't I just do this hack? And he'll be like, wow, you're super bright. So here's the hack. You're going to say D equals the change in x squared plus the change in y squared. That way we don't have to deal with that square root. And really I should have put, yeah, that's fine. All right, here we go. All I'm doing is this, guys. So let's see what the change in x is first. Change in x, that's a 7. And then the point on this curve. All right, guys, focus. The point on this curve is some x, comma, and then it's a y. But instead of saying y, I'm going to say what? Oh man, not everyone at the same time. Okay. Does everyone understand what I just did? Okay, I got a point on the curve. Focus, guys, focus. So instead of calling that curve an x comma y, I said x comma square root of x plus 4 because that's what the y value is on that curve. Does that make sense? Yeah, no, the model is what's hard, guys. The model is what's hard. But once you do a few of them, you kind of understand what's up. And this is what you're doing. This is all you're doing at the University of Physics, right? Mechanics and magnetics. You're just creating models. So this is why calculus is used in physics. All right, here we go. Yeah, if you're good at calculus, you'll breeze through physics. No, you'll be fine. All right, here we go. All I'm going to do is just that, right? So I'm going to use that. So I'm going to go D equals parentheses. It says a change in x. So I'm going to write 7 minus x, because what am I looking for? I'm looking for this horizontal displacement right here of this triangle, right? Because I'm trying to find the distance. Now I want the vertical displacement, and I'm gonna put a square on it. I didn't mean to make it violet. I just wanted to. Plus the difference in y. So the square root of x plus 4 minus 0. Are we still okay? All right, check it out, guys. They're making it kind of simple for us, kind of. 7 times 7, all I'm doing is expanding. I'm just expanding. 7 times 7, 49. 7 times negative x is negative 7x, but you're going to have how many of those? So I'm going to write minus 14x. X times x plus x squared. And then anything minus 0 is itself. So when I square the square root, it's just going to be plus x plus 4. Are we still okay, guys? All right, here we go. D equals that 49 and 4. 49 plus 4 is 53. I hope I haven't confused anyone. Then negative 14x plus x, that's going to be a minus 13x. Are we still okay? And then plus x squared. This is what I'm going to take a derivative of. All right, here we go. D prime equals negative 13 plus 2x. Equal that sucker to what? 0. Just solve for x. So 2x equals 13. Divide by 2, divide by 2. X equals 13 over 2. This is where you have a max distance. I mean, the min distance. The minimum. Let's see. If it doesn't have 13 over 2, take it out. Out, out. It's between these two. Oh, no, never mind. It's between one. It's not between two. I thought I saw 13 over 2. There it is. That's the answer. That's square root of 42 over 2. That's just the y value when you plug in 13 over 2 in here. And that's it. Okay, tell me if I'm confused. Tell me.
No, I didn't say that.
Someone said it's so confused.
Oh no, this is something else.
Oh. No, please, guys, focus, because I want you guys to be beasts. Okay. Look, notice that I'm stealing them from UH. And then I did one business. How many business majors do I have in this class, guys? I don't have any business majors? 0? Okay.
Me too.
Are you a business major? No. Minor in business? Okay. But you are something with business, right? Okay. No, for real, because it depends on whether I do this question or not.
No business majors in music.
Because you're probably going to have to take business calculus if you're going to minor in business.
That's a thing?
Yeah. All right. Here we go. Don't worry, but it's baby. It's baby. All right. A rectangular playground is to be fenced off and divided into 2 parts by a fence parallel to one side of the playground. A 240 feet of fencing is used. Underline that. That's going to be your restriction. Find the dimensions of the playground that will enclose the greatest total area. All right, guys, read the question so you guys know what's happening. Look, a rectangular playground is to be fenced off and divided into 2 parts by a fence parallel to one side of the playground. So here's my playground. And parallel, boom, right there. There it is. I got 2 sections. 240 feet of fencing is used. Okay, so horizontal distance, I'm going to say that's x. Vertical distance, I'm going to say that's y. Y. And I'm using this fencing. So I'm only using how many feet of fencing? So then I have to go 2x plus 3y, and that better equal 240 feet. Because that's all the amount of fencing I have. Cool or not cool? Now, look what we're trying to maximize. It says, find the dimension of the playground that will enclose the greatest total area. So area is still equal to x times y. Do you guys see that? And there it is. So now I'm just going to find the total area. I use my restriction. So if you just have one critical point, that's going to be your max. Sorry, guys. I'm trying to get this hair out of here. There's a dog here. All right. Yeah, it's because I have a dog. And I probably have dog hair around me. All right. Here we go. X. Here we go, guys. Here we go. I'm going to solve for y. 3y equals 240 minus 2x. Divide by 3, divide by 3, divide by 3. Y equals 8, 16, 24. Is it 80 or 8? 80. Minus 2/3 x. Have I confused anyone? We call this a restrictive equation, guys. Well, it depends. Some textbooks call it that. Some textbooks don't call it that. Area equals x times 80 minus 2/3 x. Chav, why are you doing that? I'm trying to get my derivative expression in terms of one variable. I don't want it in terms of two variables, just one. Are we okay with that? We're okay, guys? Okay. Distribute the x. 80x minus 2/3 x squared. You're done, guys. This is what you want to maximize. That's what you're going to take a derivative of. A prime equals 80 minus 4/3 x. All I did was take a derivative. Ask me, can you... Ask me, can you... Just solve for x, guys. You're done. Just solve for x. 4/3 x equals 80. Multiplied by 3/4. Whatever you do to one side, do to the other one. That's an 80 there, but I just didn't write there. So times 3/4. So then we get x equals, let's see, 4 goes into 8 twice, so 20. 20 times 3, 60. There it is. That's what's going to give me maximum area. Now, they didn't want just x. They wanted dimensions. If x is 60, how do I get the y? I come over here. Y equals 80 minus 2/3 times 60. So y equals 80 minus 3 goes into 60. What's that? 20 times? 20, 40, 60? Yep. 20 times 2? 40. So 40. So y equals 40. So what are my dimensions? 60 by 40. And we look for that. 60 by 40. Here it is. How do we feel, guys? Yeah, it's not bad. It's not bad. All right. Do we have business majors? Be honest. No? Okay. Then we're going to skip this question. It's just a business calculus question. This is what business calculus is about. But relax, business calculus is a watered down form of calculus. So you should be in the clear if you go that route. All right, guys, just take care of that activity and we'll call it a day.